Hello everyone, this is pre-algebra. We're gonna jump into topic 7 today. Analyze and solve linear equations. In this topic, we will think about how we can analyze connections between linear equations and use them to solve problems. As you can see, we have 9 lessons total. We'll look into linear equations later on, but we'll start with just general equations. So the topic vocabulary are slope of a line, slope-intercept form, and y-intercept. If you scroll down, there's topic 7, get ready part. And this is, these are the vocabularies and skills that you need for this topic prior to learning them. So on page 399, let's review what we know. So vocabulary, which is the best term for the box to complete each definition. That's number 1, 2, 3, and 4. And an algebraic expression will link our terms that have the same variables raised to the same exponents. Is it an inverse operation? Is it like terms? Is it proportion? Is it variables? It is like terms. These are terms that have the same variables raised to the same exponents, so you can add or subtract these like terms. Number 2, quantities that represent an unknown value are blank. The unknown value that we're usually solving for are the variables. Number 5, a blank is a statement that 2 ratios are equal. Ratios are equal. So 2/4 is equal to 1/2. These are ratios. Or 2/4 is equal to 1/2. It's a proportion. And the last one, operations that undo each other are called inverse operations. So undo means if you have +2, if you subtract 2, you have 0, right? So that they basically undo each other. Okay, see if you can solve these by yourselves and identify like terms, solve one-step equations, and simplify fractions, and come back when you're ready. Okay, so in number 5, 4x and blank are like terms. You need to have the same variable raised to the same power. 4x and -9x are like terms. So if it's a subtraction, that comes with your term, okay? 7y and blank are like terms. It's not -6z, it's +6y. Okay, number 6, 1/2s and blank are like terms. Where's another term that has s? 2s are like terms. Okay, 6u and blank are like terms. -9u, include the negative. All right, number 7, simplify each equation. What is x? 2x is equal to 10. That means x must be equal to 2 times 5 is equal to 10. So x is equal to 5. Okay, divide both sides by 2, and that will undo your multiply by 2 factor. So number 8, x plus 3 is equal to 12. Subtract 3 on both sides and you get x is equal to 9. Number 9, x minus 7 is equal to 1. You add 7 on both sides and you get x is equal to 8. All right, we simplified the expressions by solving for x. Let's simplify fractions on number 10. Explain how you can simplify the fraction 12 over 36. How do you simplify fractions? First, you can find the greatest common factor, GCF, of the numerator and denominator. Then you can divide the numerator and denominator by the GCF. And in this fraction, the GCF is 12. So in simplest form, the fraction is 1 over 3. Okay? So first find the GCF, divide the numerator and denominator by the GCF. And in this fraction, GCF is 12. So the fraction, that is the simplest form, that's equivalent to this fraction is 1 over 3. Okay, the next page, language development. Fill in the Venn diagram to compare and contrast linear equations of the form y is equal to mx and y is equal to x plus b. What are some examples for these forms? Your x and y are variables in the equation. Okay, so they're always going to be x or y in your equation, but you need to know the slope and the y-intercept. They're going to be the constants here. So example, y equals 2x is in the form of y equals mx. Example, y equals x plus 2 is another example. Are they the same thing? No, they're not. What's the difference between them? What do you see? You see M and B, right? Here, the equation has a slope. Here, the equation has a y-intercept. Okay, do you see other differences? If not, we can come back. What are some similarities that you see? What do they have in common? They are both linear equations, right? So you can say they are both linear equations. You can put the similarities on the overlapping area. Okay, what else? Okay, we can come back whenever we're ready again as we learn in this topic. Okay, but you need to know the meaning of slope-intercept form, where you will have both of them. Y equals mx plus b, as it is in our class wall, is called the slope-intercept form. You have the slope and the y-intercept, and that's why it's called slope-intercept form. And we'll look more into it. We'll learn more about it in the lesson as we go over topic 7. Okay. In the box below, draw graphs to represent each form of the linear equations. So if you were to look at it in a graph, for example, y equals 2x versus y equals just simple x versus y equals x plus 2. Let's draw that. Okay, y equals x will have a slope of 1 and it starts with 0. 1, 1, 2, 2. When x is 3, y is 3. And so it's gonna look like that. Y is equal to 2x also starts with 0. But when x is 1, 1 times 2 is 2. So you have 2. And then when x is 2, you have 4. When x is 3, you have 6. So then it's growing much faster than y equals x. But they're both linear, right? What about y equals 2x plus 2? Well, when x is equal to 0, your y is 0 plus 2. So that means you have a starting y-intercept at 2. Okay, it doesn't start from 0. When x is 1, it becomes 3. When x is 2, y is 4, and so on. So it has the same slope of y equals x, but it starts at a different point. Okay, so these are just a simple overview of the differences between the linear equation that has the slope and that has the y-intercept. What if they have both? We'll explore more about it. These are some topic projects that you can choose from. Let's go to lesson 1. Lesson 7-1 is combine like terms to solve equations. In this lesson, we'll be able to solve equations that have like terms on one side. Explore it. A superintendent orders the new laptop shown below for 2 schools in her district. She receives a bill for $7,500. So altogether, it's $7,500. Okay. And how many laptops do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 laptops that we can see. And altogether, it's $7,500. Okay, so part A, draw a representation to show the relationship between the number of laptops and the total cost. We can say number of laptops would be X, and then the total cost would be Y. And we can say we have 3 laptops here. So 3x, and then 1, 2, 3, 4x. Now we have another 3x. Okay, so these are number of laptops. 1x is a laptop. So together we have 10x, and that's equal to $7,500 together, right? These are all, it's there in total, it's 10x, but it's also $7,500. Okay, so they're equal to each other. Part B, use the representation to write an equation that can be used to determine the cost of one laptop. So using the linear equation, 10x is equal to 7,500. What is the cost for one laptop, which is X? 7,500 divided by 10 would give you an X, which is $750. So one laptop would cost $750. Okay. Why is it important to know that each laptop costs the same amount? Why? If the laptops don't cost the same amount, what happens? You couldn't use the same variable to represent the cost of each laptop because they're not the same, right? And there's really no way of figuring out what the cost is for one laptop because it's all different. So if the laptops have different costs, we could not use the same variable to represent the cost. Okay, so let's think about how we can solve equations that contain like terms. Look at example 1. Combine like terms to solve addition equations. Gianna has 36 yards of fabric to make sets of matching placemats and napkins. How many matching sets can she make? Why can you use the same variable to represent the number of placements and to represent the number of napkins? So, because they represent the same thing, X is the variable that represents the number of sets of matching placemats and napkins, right? So you can use X as a variable. The whole thing, you can use the bar diagram to represent the situation. The whole thing is 36 yards because she has 36 yards to start with. And you know that the matching fabric she has are 1 1/3 yard and 1/6 yard. So together, they're gonna make, together you know it's 36 yards, right? So yards of fabric needed to make X placemats, and yards of fabric needed to make X napkins. So you're gonna cut so that you can match them. So you can represent that using X, because every time you cut one here, you're going to cut another one here as well. So 1 over 1/3 times X is going to be how many number of sets of matching placemats and napkins you will have together. So, and that's going to be in total 36 yards. Okay, so this times that times that, right, it has to be 36. And solve for X by combining like terms, because 1 over 1 and 1/3 is 8 over 6. 8 over 6 and 1 over 6 could be added together because they're like terms. They're the terms that have 1x, right? And so you add them, you get 9 over 6x. And in order to undo the multiplication of 9 over 6, you do what do? You multiply the reciprocal of that. The reciprocal of 9 over 6 is 6 over 9. If you multiply them, you're basically gonna get 54 over 54, which is 1, right? 54 over 54 is 1. So that's 1x. That's equal to 24 if you multiply 6 over 9 times 36. So she has enough fabric to make 24 matching sets of placemats and napkins is the answer. All right, let's look at try it. Selena spends $53.94 to buy a necklace and bracelet set for each of her friends. Each necklace costs $9.99 and each bracelet costs $7.99. How many necklace and bracelet sets did Selena buy? Okay, so you can represent the situation using the equation. What S plus what S is equal to 53.94. The different bracelet costs, right? So 9.99S plus 7.99S would equal to 53.94 because S represents the number of necklaces and bracelet sets she buys together. Okay, so and that's the total. So combine the like terms, 9.99 plus 7.99 is 17.98. And so 53.94 divided by 17.98. Divide 17.98 on both sides. And that's going to give you 1S is equal to 3. So she buys necklace and bracelet sets for 3 friends. Is the answer. Okay, convince me. Suppose the equation is 9.99S plus 7.99S plus 4.6 equals 53.94. Can you combine the S terms and 4.6? Are they like terms? can you add them together and say, oh, instead of 17.98s, we're gonna get 22.58. Can we do that? No, because they're not like terms. You can't add them. So no. Because the S terms contain a variable and 4.6 does not. They are not like terms. And we cannot okay, so please keep that in mind. You can only add and subtract like terms to combine them. Okay, let's look at the next page. Example 2. Combine like terms to solve subtraction equations. Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale? Do you guys remember the part and the whole equation we did last topic? Yeah, so P is the whole here, right? P is the price of the screen before the sale. And then we took 35% off to get $130 after the sale. So how do we figure out P? You can simply write a subtraction equation. P minus 0.35P is equal to 130. And you can combine the like terms and say, oh, 0.65 times P is 65% of the original is what we have right now, which is 130, right? And solve for P by dividing 0.65 by on each side, and P is 200. So 200 was the original price. Okay. So let's look at try it. Can you do this try by yourself? Come back when you're ready. Okay. Now, are you ready? Nat's grocery bill was under $50, which included a 5% club discount. What was Nat's bill before the discount? Write and solve an equation. So it's very, very similar to example 2, right? It is basically example 2. So first, let's decide what the variable is going to be. You can say C is going to be the cost of groceries before the discount. Okay. And how can you write an expression to represent the situation? You can say the original cost minus 0.05 times C, which is 5% of the original cost, is 150. And solving for that, you can say 0.95 times C is 150. Only 95% of the original cost is paid, which is 150. So divide both sides by 0.95 and you get C is equal to 150 divided by 0.95 is 157.89. And yes, it should be greater than 150 because 150 is after you got a discount. So just remember, if you got something like smaller than 150, that's not, something's not correct, okay? So what was the bill before the discount? $157.89 is the correct answer. Okay, let's look at example 3. Combine like terms with negative coefficients to solve equations. What if we have negative coefficients? Let's solve this equation. We have a like term right? The y terms. So you can combine them. Negative 3.5 minus 6.2 is a greater negative. So negative 9.7y. And that's equal to negative 87.3. If you have a negative, then you just divide the negative as well. Because if you don't, what happens? If you just divide it by 9.7, that means you still have negative 9, which is equal to negative y, which is equal to negative 9. That is not the correct answer. You're not done. You have to multiply or divide the negative sign at the end as well on both sides. Okay? So don't forget to include the negatives when you're dividing the negative coefficients. If you have a negative coefficient in front of your variable, you have to get rid of that negative at some point. Because solving for the variable means solve for the positive variable. All right, let's look at try it question. Please solve for D in parts A and B and come back when you're ready for answers. All right, are you ready? Part A, negative 1 over 4D minus 2 over 5D is equal to 39. They're like terms, so you need to add them, right? Negative, you multiply to 20, so negative 5 over 20 minus 8 over 20 D is equal to 39. And that's gonna be negative 13 over 20D is equal to 39. And so you're gonna multiply negative 20 over 13 on both sides. And then you have D is equal to, that's 3. So negative 20 times 3 is negative 60. So D is negative 60. What about the D in part B? Since the variable is the same, let's change the color. Okay, these are like terms, but before you add, can you simplify these? There's a parenthesis, so let's get rid of the parentheses. You can't just get rid of the parentheses and say, oh, that's negative 12.881D. You have to multiply the negative out to the parentheses, okay? So that means you have negative 9.76D plus 12.81D because you cancel out the negatives, okay? And then you can add the like terms. 12.81 minus 9.76 is 3.05D. That's equal to 8.54. So 8.54 divided by 3.05 is equal to 2.8. So D here is 2.8. Okay, did you get them right? If so, good job. Let's summarize our lesson. So we learned how to solve equations. In an equation with variable terms on one side, you can combine like terms before using the inverse operations and properties of equality to solve the equation. So if you see like terms, combine the like terms first so that it's easier later. Okay, and if you have a negative coefficient, don't forget to divide or multiply the negative coefficient on both sides. All right, that was lesson 7-1, combining like terms to solve equations. In the next lesson, 7-2, we'll learn about solving equations with variables on both sides. So if you have any more questions, please ask Ms. King in class, but I'll see you in the next video. Bye.